suppose that a product has been rated by customers with the ratings given below, these ones. So 40 people gave 5 star, 35 people gave 4 star, 10 people gave 3 star, 10 people gave 2 star, and 5 people gave 1 star. So if you choose one of the rating randomly from this set, what is the probability that that rating is going to be 4 star or 5 star? This session is about answering these types of questions. This is about probability. By the way, the answer is 75%. So, what exactly is probability in plain English? Well, think of probability as a measure of uncertainty. Whenever you are unsure what will happen, for example, let's say you roll a dice and you don't know what you're going to get 1, 2, 3, 4, 5, or 6, or maybe you're predicting a rain. You step outside your home, you don't know whether it's going to rain or not. Is it 20% chance, 30% chance? Or after you give an interview, you don't know whether you're going to get a job offer. You're maybe 60% sure, maybe you're 90% sure. So you are thinking in terms of probability there. So before I give the formal definition of probability, let's try to understand few key terms. Sample space. This represents all possible outcomes. So let's say you toss one coin. In this case, you can get either a head or a tail, right? Head or a tail. So the size of my sample space in this case is 2. How about if you toss two coins, these two coins? Well, you can get either a head, you can get head tail, you can get tail head, or you can get tail and tail. So size of my sample space in this case is 4. How about if you toss three coins? Well, you can get head, right? You can get head, or you can get head, tail, or you can get head, tail. So you can have all these possible outcomes. So all these possible outcomes, this is your sample space. Size of my sample space over here is 8. How about if you roll a dice? This is the dice I roll. I can get anywhere a number between 1 to 6. So in this case, my size of my sample space is 6. How about if you draw a card? Well, you can get any one card, right? There are 52 possible outcomes over here. So the size of my sample space in this case is 52. Now let's try to understand events. It is defined as a subset of your sample space. So let's take a look at some examples. Let's say in a one coin toss trial, the event in this case could be getting a head, just head. So in this case, the size of my event is 1. So if you draw this thing using a Venn diagram, so this is my Venn diagram, this is my sample space, this consists of tail and a head. And my event, okay, it has only one element, head right here. So it is a subset of my sample space. How about in a two coin toss trial? So in a two coin toss trial, your event maybe could be getting the same outcome. So in both the toss, so in this case, you can get head and head or tail or tail. So coming back, if you come down right here, okay, this is my Venn diagram for this particular trial. So in this case, I'm tossing my coin twice. So you can get head and tail, you can get tail and head, you can get head and head, or you can get tail and tail. And my E, my event E is going to be getting the same outcome in both toss, which will be this right here, head and tail and tail. Okay, how about you do a three coin toss trial right here, three coin toss trial, which would be right here. So I toss three coins, and in this case, my event, it could be getting exactly one head. Well, my outcomes could be head, tail, head, tail, and tail, head. So the size of my event is 3 in this case. So if you write all your elements in your sample space, it's going to be tail, head, head, tail, and all these elements. Now my E, which is my event, as you can see, it is a subset of your sample space, and my event in this case is head, head, tail, head. So all of them are exactly one head. Okay, what about if you roll a dice? If you roll a dice, your event, let me just remove everything. Okay, if you roll a dice, your event could be maybe, let's say, getting an even number. So in this case, my event E would be 2, 4, 6, and the size of my E is going to be 3 because there are 3 elements. How about you draw a card? In this case, maybe your event could be you draw a card that is an ace. Well, you can get an ace of heart, ace of diamond, or you can get ace of clubs or ace of spades. So there are 4 different outcomes. In this case, the size of E equals to 4. Now let's try to understand the probability of an event E. The probability of event E is defined as the number of favorable outcomes divided by total number of outcomes. That is the official definition of your probability of E. Another definition, this is a more theoretical definition, is probability of E is given by the size of E divided by the size of your sample space. Okay, this is another definition. For the most part, we would be using this definition. They both are basically are same. So let's say in a two coin toss, question is what is the probability of getting both heads? This is your question. So here my sample space. First find your sample space. In this case, it's a two coin toss experiment. Because of two coin toss experiment, these are all your outcomes: head head, head tail, tail head, tail tail. So these are my outcomes right here. Okay. Now what is my E in this case, my event E? Well, look at the question. The question is, what is the probability of getting both heads? So this right here is my event E right here. Okay, this represents my event E. So my event E is both toss are head. And what are my event E, by the way? Head and head. These are the only possible outcomes. So this is my event E right here. So the size of E in this case is 1 because there is only one element. So the probability of E is 1 over 4. I'm using this formula to derive or to come up with this answer right here. Suppose now you perform a three coin toss. In other words, you take three coins and you toss them. So what is the probability of getting exactly two heads? What is the probability of getting at least one head? What is the probability of getting all tails? So in these types of questions, you always start with your sample space. You find your sample space. So look at all the possible outcomes I can get. I can get all heads, right? I can get head, head, and head. So this is my first outcome. My second outcome can be head, head, or tail, right? Head, head, tail. And likewise, I can do all of them. So these are my all possible outcomes. The size of my sample space in this case is 8 because there are 8 possible outcomes. Okay, now let's do question number A first. Exactly two heads. So in this case, my event E is exactly two heads. So getting exactly two heads. Well, what are my possible outcomes? The only way you can get two heads is these ones right here. Head, head, tail, head, and tail, head, head. So the size of my E is 3 in this case. So the probability of getting E is equal to 3 over 8. I'm using this formula right here. The probability of E is equal to size of E divided by the size of your sample space. Okay, what is the probability that you get at least one head? Well, the event E in this case is at least one head. Well, what are my possible outcomes in my event E? Well, head, 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 tail, head, tail, head, and tail, head, and tail, head, tail. So these are all my event E in which there is at least one head. And size of my E is 7. So the probability of E is going to be 7 over 8. Again, I'm using this formula right here. The event E, the last one, all tails. Well, there is only one possible outcome when you have event E. In this case, there's only one element: tail, tail, tail. The size of E in this case is 1. So the probability of E in this case is 1 over 8. Suppose your inbox contains following 7 emails. Okay, this one is spam, spam, non-spam. This is a spam. This email is spam. This email is not spam, and this email is not spam. If you randomly pick one of the email from here, what is the probability that the email is a spam message? Well, first find your sample space. My sample space is this right here: spam. The first email is spam. The second is spam, non-spam, spam, spam, non-spam, and the last email is non-spam. So this is my sample space, and the size of my sample space is 7. The event E is that the mail opened is a spam. Okay, so in this case, this will be spam, 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 spam. So there are basically 4 spams, right? 1, 2, 3, 4. So this is my event E right here. So the size of E in this case is going to be 4. So my probability of E is going to be 4 over 7. I'm applying this formula right here. Suppose that a product has been rated by customers with the ratings given below. This is my rating right here. Okay, 40 people gave 5 star, 35 people gave 4 star, 10 people, 10 customers gave 3 star, 10 customers gave 2 star, and 5 customers gave 1 star. So if you go inside the rating and just randomly pick a rating, what is the probability that it is going to be either a 4 star or it's going to be higher than that, either 4 star or a 5 star? That's what basically this means. Okay, so in these types of question, the first thing you do is find the size of your sample space, because to find the probability of E, I don't really need to know what is the size, what exactly my sample space is. I'm working with the size. That's all I need to know. Size of my E and size of my sample space. Well, the size of my sample space in this case is going to be 40 plus 35 plus 10 plus 10 plus 5, because these are all the ratings, right? 40 people gave, there are 40 ratings with 5 star, there are 35 rating with 4 star, there are 10 ratings for 3 star. So you see, I just count the ratings. Okay, so the answer comes out to be 100. So the total size of my sample space is 100. Now comes my event E. Well, look at the question. It says, what is the probability that it is a 4 star or higher? So my event E in this case is going to be that the rating is 4 star or 5 star. Well, again, you don't need to know your E, you just need to know the size of your E. So in this case, size of my E is going to be the number of 4 star, right, and number of 5 star. So number of 4 star plus number of 5 star is 35 plus 40, and the answer is 75. So the probability of E is going to be 75 divided by 100. I'm using this formula right here. Okay, and this gives me the answer: 75 divided by 100 is equal to 0.75.